This is a Math 3 summary video for the lesson titled Getting to the Root of the Problem. This is a solidify understanding task. The purpose of this lesson is for students to find the roots of a polynomial and write polynomials in factored form. If you know that 7 is a factor of 147, what would you do to find the prime factorization of 147? Well, I would make a factor tree. And I know that 7 is one of the factors, so then I can divide 7 into 147. So 7 into 147 is 21. Now 21, I know that 7 is a factor of 21, and when I divide 7 into 21, I get 3. So the prime factorization is 7 squared times 3. The process for finding factors of polynomials is exactly like the process for finding factors of numbers. We start by dividing a factor we know and keep dividing until we have all the factors. When we get the polynomial broken down into a quadratic, sometimes we can factor it by inspection, and sometimes we can use our other quadratic tools, like the quadratic formula. Let's try it. All right, so we need to divide x plus 3 into our polynomial x cubed plus 3x squared minus 4x minus 12. So I ask myself, what times x gives me x cubed? And that would be x squared. Then x squared times x is x cubed. X squared times 3 is 3x squared. Subtract is 0, so I can go ahead and bring down the minus 4x, and I'm going to go ahead and bring down the minus 12. So what times x gives me negative 4x? That would be negative 4. So negative 4 times x is negative 4x, and negative 4 times 3 is negative 12, and when I subtract, I get 0. So now I have that x plus 3 times x squared minus 4 equals f of x. So my quadratic right here can be factored even further. So I'll bring down my x plus 3, and this is the difference of squares, because x squared is a perfect square and 4 is a perfect square, and it's subtracting. So I know that if I factor x squared minus 4, I'll get x plus 2, x minus 2. So now I have my factored form, and I can use that to find my roots. My roots will be x equals negative 3, x equals a negative 2, and x equals a positive 2. And I got that by just taking the opposites of each of those numbers. Number 5. Let's start with our long division. So I again ask myself, what times x gives me x cubed? It would be x squared. When I multiply x squared times x, I get x cubed. X squared times negative 5 is negative 5x squared. Then I'll subtract. So subtracting a negative here is like adding. So I have 0, which means I'll just bring down what I have left. And negative 3 times x gives me negative 3x. Negative 3 times negative 5 gives me a positive 15. When I subtract, again I get 0. So I have in factored form x minus 5 and x squared minus 3. X squared minus 3 does not factor, so I'm just going to leave my factored form the way it is. However, I do have more work to do to get my roots. I know that one of my roots is x equals 5, but my other root, I need to set x squared minus 3 equal to 0 and solve. So I'll add 3 to each side, and then take the square root, and I get a positive and negative square root of 3. So my roots are x equals a positive square root of 3 and x equals a negative square root of 3. I could also take my roots and write the factored form as x minus 5 times x minus square root of 3 times x plus square root of 3. This is another equivalent equation. Let's take a look at another problem. Here I have the function f of x equals x cubed minus x squared plus 4x minus 4. And my factor is x minus 2i. So it's cubic. I know that I have 3 roots, and I know that one of them is x equals 2i. If one of them is positive 2i, then the other one has to be negative 2i, because these complex roots, these non-real roots, come in pairs. Because we know two of our roots, let's go ahead and get two of our factors. So that would be x minus 2i and x plus 2i. We do know that there is a third factor, and we know that our third root will be a real number. Let's go ahead and multiply these two factors together. I have x squared plus 2i minus 2i minus 4i squared. So that's x squared, positive 2i minus 2i. Those will cancel each other out. And then I'm left with minus 4i squared. I squared is negative 1. So negative 1 times negative 4 will be plus 4. So what I'm going to do now is take my x squared plus 4 and divide it into x cubed minus x squared plus 4x minus 4 to get my third factor. So x times x squared gives me x cubed, and that'll be plus 4x, so 0x squares plus 4x. So I'll subtract, and I'll get negative x squared, and then bring down this minus 4. And negative 1 times x squared gives me negative x squared, so I'll get negative x squared. Negative 1 times 4 gives me negative 4. So when I subtract, these subtracting a negative turns into adding, I get 0. So since 0 is my remainder, then I know x minus 1 is a factor. My factored form will actually be f of x equals x minus 1 times the quantity x minus 2i times the quantity x plus 2i. If you were asked to write your factors so that they did not contain imaginary numbers, then it would be f of x equals x minus 1 times the quantity x squared plus 4. My third root was a positive 1. This chart summarizes the function with a degree and the different types of roots that you can have. So linear functions have a degree equal to 1. So they have one real root. The only possibility is one real root. So there will be one x-intercept for the one real root. For quadratic, you can have 0 x-intercepts, which means 0 real roots and 2 non-real roots. So when you have a real root, you have an x-intercept. So for a quadratic, you can have one real root with a multiplicity of 2. And notice here where you have the multiplicity of 2, your function is changing direction right on the x-intercept. And then, of course, you can have 2 real roots, which gives you 2 x-intercepts. For cubic, you can have 1 real root and 2 non-real roots. So that's what this will look like, where you have that 1 x-intercept. And the change of direction here is happening above the axis. And keep in mind, these are just like one little sketch. Your functions could look different, but still have these same characteristics. You could have one real root with a multiplicity of 3, just like the parent function, f of x equals x cubed. You could have 2 real roots, where one of these roots has a multiplicity of 2. That would happen right here, where the function's changing direction, right at the x-axis. And then here's the other root. Or you could have 3 real roots where you have 3 x-intercepts. Alright, that's it for this video. Thank you for watching.